Want some bite size? Yum!
Hey guys, Mr. Dave here with another edition of Bite Size. Before we do anything else, I'm going to take this and I'm going to pour it into this. And I'll tell you why in a minute. I'm mixing it up real good. All right, now we're going to see why we did that first. Start the clock. All right, this is Mr. Dave from the National Museum of Nuclear Science and History. We are doing what is called a clock experiment. I did that first so you can watch that. Yeah, I poured that back and forth and nothing happened yet. Things are happening, but we're not able to see them. This is bite size, so every experiment, every demonstration we do, we give you a difficulty rating, okay? I know everyone's stuck at home right now, did you see that? What just happened is this is an iodine clock experiment. It took a while for it to happen, and I'm going to show you why. First, I'm going to show you our ingredients for our clock experiment, okay? We had there in those glasses is we had this one here, which is just vitamin C and iodine, okay, and water, okay. So we have our vitamin C, our iodine, and water. Now I want to show you something cool here that happens when you pour that iodine into that vitamin C. First, this is the first fun part of the experiment. There you go. Okay. You can see that that iodine goes from that brown to clear right away. Now this is kind of yellow, and that's because I only had the vitamin C I had in my house, and it's the chewables with the food coloring in there. Okay. So this one is vitamin C and iodine. Okay. We'll put all the ratios again down in the description of the video. Okay. So that way you don't miss any. Our second little glass that we had here is actually hydrogen peroxide, okay, and starch, just your regular household laundry starch that you use for making your clothes nice and stiff if you do that, mainly that you have at home for making slime. When we poured these two together, when we poured this one into this one, the water I used was very hot, okay, so I had hot water in both. Now what we had here, when you saw nothing happen for a while, that's our clock part of the experiment. Now that's a part that you guys can, at home, you can experiment with some different things, okay? Ours happened in really less than a minute, okay? In the video here, it actually took about 5 minutes, Okay, and that's because I had cooler water. Now, the things that you can change in this experiment are your different amounts of your vitamin C, okay, and the different temperatures of the water. As you can see, even though all of my ratios were the same as in the video of me putting these things together, even though the ratios, the stoichiometry, that's a big word, meaning if you increase this in chemistry, you have to make sure you increase everything else and keep everything to where your ratios are the same, okay? Stoichiometry. Look it up. That's a fun word. It sounds fun. It's just fun to say stoichiometry. Okay, so make sure your levels are the same. Even though the stoichiometry, our ratios were the same on these ones here, I heated the water, and that changed my clock time on this experiment. If you use cold water, I wonder what would happen. Okay, so things that you can take this fun, quick little experiment, you can take it and you can use math. Okay, if you use that stoichiometry, the math on this one would be, okay, well, if I end up increasing my amount of C, maybe I want to do this in a big pitcher. Okay, if I increase the C, how much would I have to increase my peroxide and my other components of this? Okay. So on a scale of 1 to 5, if one was the chemical composition of water, which is H2O, and the other was the chemical composition of mycotoxin, which is a whole bunch of letters, this would probably be about the equivalent of salt. Okay. Now, if you can figure out that chemical composition, the chemical composition of salt, put it down in the comments. I'll give you a shout out in one of the future ones. This one here is probably maybe a 2. Now, I rate it as a 2, not because these things are difficult. You probably have these things in your cabinet at home, but there is chemicals involved, and you want to make sure that you are safe anytime you're using chemicals, and iodine can really stain stuff. So be careful with that. Don't get it on your best shirt. Don't say, hey, I'm going to wear my best shirt and I'm going to... Don't do that, okay? So don't be getting iodine on your best shirt or the carpet, okay? So keep that off of stuff. This peroxide, the peroxide that we're getting here is a pretty safe level of that peroxide, but anytime you're using this, or you using any kind of chemicals, make sure you got your parents around. Okay, so this again was our iodine clock experiment where we saw that glass, we saw that color change, whoosh. Okay, now what's really cool is if you do have vitamin C that doesn't have the food coloring, because then this is actually an almost clear mixture. You have a little bit of fogginess from that starch, but it's almost a clear mixture, and then that change is even more dramatic. So if you have vitamin C that is with no food dyes and things like that in there, that makes this even more fun. So again, ways that you can take this at home, you can make a big project out of it, is to work with the math on the stoichiometry, okay? You can figure out different ratios for making a larger experiment or a smaller experiment, okay? That one's math. You can also just check things like for the little guys, you can do it with hot and cold, okay? So keep everything the same. Try this experiment with cold water and then have your little guy watch and see how long that takes. Try it with really hot water and you saw that it was in under a minute. Okay, so with cold water though, be ready for the long haul. You may want to, set it in the room while you're doing something else, while you're figuring your math for your stoichiometry. I'm just trying to say that word as many times as I can because it's awesome. I'm Mr. Dave from the National Museum of Nuclear Science and History. This one does involve chemicals. Make sure you have an adult around because I'm sure they're going to have fun with you. And what I got to say next is thank you. We have now reached over 100 subscribers, so I really appreciate that, guys. If you like these experiments, if you like these demonstrations, share them with your friends. Make sure you like and subscribe. I'm Mr. Dave from the National Museum of Nuclear Science and History, and wash your hands.